Hello everyone, in this video let's discuss how to solve the ambiguous grammar problem in theory of computation. So if you see the theory, that is the definition of ambiguous grammar is a grammar can be called as the ambiguous grammar if it has more than one parse tree. So if you are successful enough to draw more than one parse tree for the given set of grammar, you can call it as the ambiguous grammar. Now let's consider these two examples and try to solve the problem on the ambiguous grammar and check whether they are ambiguous or not. Now, first question. So what is the production? E is producing E plus E. Next, another one. This E is only producing E star E. This slash represent, this is a separate projection produced by the same producer. So E is producing E star E. Next, this is the separate projection produced by the same producer E. So E is producing ID. So these are the three separate projections. Since the left hand side is equal in the all three projection, you can write it in the single line only. Now what I will be doing is, I will be trying to construct more than one parse tree. That is, if I construct two parse tree also, I can say this grammar as an ambiguous. Now, first one. So first, E is producing E plus E. E plus E. Next, E is producing E star E. Now I can consider this E or this E. So let me consider this E itself. So E producing E star E. Next, E producing ID. Wherever E is at the last, that is at the leaf node, just write ID. ID. Here also I will be writing ID. Here also write ID. Now travel from left side towards the right side using the leaf nodes. So which is the leaf node? ID plus ID star ID. So what is my string? My first string of A is ID plus ID star ID. Now let's try to construct the another parse tree, B. So E producing at the initial or in the A, I took E producing E plus E at the starting. Now let's consider E producing E star E. So E producing E star E. And another projection is E producing E plus E. So what I must do is, where I took the branches for the E in the previous one, so there only I must take the branch. So E plus E, and E producing ID is left. Wherever E is at the leaf node, write ID there. So travel from left to right. ID star ID plus ID. So ID star ID plus ID. If you see the first of A and B, both strings are different. ID plus ID star ID, ID star ID plus ID. So both are different. So I produced the different parse tree, and I producing more than one parse tree. So I can call this grammar as an ambiguous grammar. Therefore, this grammar is ambiguous. Ambiguous. So this completes the first question. Now let's move on to the second question. So the second question is S producing A, S, B, S, and next S is the producer of another separate projection, that is B, S, A, S. This S is the capital letter. Next S is producing another projection, that is epsilon. Now let's try to construct true parse tree A and B so that we can tell it as an ambiguous grammar. So first I will take this projection, S producing A, S, B, S. One thing you keep it in mind, you can only expand the capital letters, you can't expand the operators, that is plus, minus, into, you can't expand them, and you can't expand the small letter. You can only expand the capital letter, that is you can write the branches, and you can go with the answer using the capital letter itself. Now, S producing BSAS. So you can take for this capital letter S or this capital letter S. So let us go with this one only. Anything you can do. So B, S, A, S. Another projection is S producing epsilon. Wherever capital letter S is in the leaf node, just write epsilon. So here epsilon, epsilon, epsilon. Travel from left to right. A, B, epsilon, A, epsilon, B, epsilon. So what is my string of A, B, epsilon, A, epsilon, B, epsilon. Just write the leaf node answers. That is, there is no further child for them. Now let's construct the another one pass tree. In the first one I consider this projection first. Now I will consider this projection. S producing B, S, A, S. Now here I branched for this S. Here also I must branch for this S only. So another projection is AS, BS. A, S, B, S. Next, left out projection is S producing epsilon. So epsilon, epsilon and epsilon. Now travel. B, A, epsilon, B, epsilon, A, epsilon. You must travel using the leaf nodes. That is no child further. B is the small letter B, A, epsilon, B, epsilon, A, epsilon. If you see, both these strings are different. So we are successful enough to draw the more than one parse tree for the second question also. So you can say this is also this grammar is ambiguous. Ambiguous. So your only intention must be to draw more than one parse tree and generate the different kind of strings using the leaf node. So hope you understood the concept how to solve the ambiguous grammar problem. If you have any doubt, please comment below. I will clarify it. If you liked the video, please subscribe and support us. Thank you.